the end of this tutorial, you'll have a solid understanding of VPC concepts, the ability to create and manage your own custom VPC, and the knowledge needed to design secure and scalable network architectures in AWS. Hi, I'm Elias Saunders, and I'm a DevOps analyst at Smoothstack. Amazon Web Services offers a powerful networking service called Virtual Private Cloud, which allows you to create and manage your own isolated network environment within the AWS cloud. This tutorial will take you through the fundamental concepts and practical steps to set up and configure an Amazon VPC. Before we begin, ensure you have the following: an AWS account, basic familiarity with AWS services, and access to the AWS Management Console. Without further ado, let's see it in action. Ready? All right, let's get started. First things first, you're going to go up here and you're going to click Create VPC. Now, there are two options. You can create just the VPC, or you can create the VPC and a bunch of other networking resources. For now, we're just going to do the VPC, as I'll show a manual setup for the rest of it. Now, you need to define a tag for your VPC. Any resources that live within this VPC will also have this tag, so make it something recognizable. Go with test. Now you define what kind of IPv4 CIDR block you're going to use, whether that's just manual input or IPAM allocated. IPAM just stands for IP address management, and abstracts away the CIDR block definition, so we're not going to mess with that for now. Just keep it manual. I'll define this as 10.0.0.0.16. And I'll go over this right now. This is an important part of the setup. It defines the IP range allowed within this private cloud. So for a second, think that each portion, that being each period after, represents 8 bits. The final portion of the block, this being the CIDR portion, determines that only the last 2 slots can change, referring to the 8 bits on each of these 16. I'll go into it a little more when we get into subnets, but for now, this is just a quick starter into that. Next, you can determine if you're going to use any IPv6. IPv4 addresses are 32 bits, IPv6 128 bits, and hexadecimal, meaning there's a whole lot more you can use. But for now, we're just going to keep it IPv4. Then your tenancy is the hardware that is hosting your VPC. How do you want it? Now, this gets more specifically into EC2 instances running on your VPC and exactly how that hardware is allocated. So shared means that all accounts in the universal AWS space can utilize that same hardware. Dedicated, which designates the hardware for a single tenant, and a dedicated host is a specific physical server for an instance. We're just going to keep it as default, which means that the actual tenancy is defined by the EC2 and not by the VPC itself. We'll go down and we'll go ahead and create it. All right, with our VPC created, we are now in the VPC console. Here we can see a bunch of details on our VPC, and also over here there's a resource map, which is pretty cool because it's basically going to be showing us what we're going to be spinning up for the rest of this tutorial. So first things first, we'll be making some subnets. Go over here, go up, create subnet. There are 2 main types of subnets, public and private subnets. We'll go into the differences once we get to the route table. But for now, we'll go ahead and click our VPC. We'll call this test pub. This will be our public one. No preference for the availability zone. Now we'll do another example of CIDR here. Since our IP range for the VPC is 10.0.0.0 to the CIDR block of 16, we're going to do 10.0.1.0.24. Now, this determines that this subnet can have an IP range of this number here up to 10.0.1.255, meaning 256 IPs. So, with that, we're going to define our next one, which will be the private subnet. So, go here, test priv, and then for this one, we'll do 10.0.2.0.24. So anything in this subnet will be within pretty much a very similar range, but with a 2 here instead of the 1. All right, we'll go ahead and create those. All right, with our subnets defined, we're going to go into the route tables and we're going to define these subnets to be public and or private. So the public subnet has the ability to send and receive traffic from the internet. And in order to do this, we're going to need something called an internet gateway. So we'll go over here and we'll create one. We'll call this test IG. Go ahead and create that. All right, so first thing we need to do is we need to attach this to a VPC. Go up here, pretty straightforward, allows us to hook it up. All right, now that's not the only thing we need to do in order to define our subnet, as it's just on the VPC and there's two subnets in there. So what we're gonna do is we're gonna go to the route table. This one's associated with test. As we can see, neither of the subnets are associated to this route table. So first things first, we're going to define a new route, and this is going to be for the internet gateway. So traffic from any IP through internet gateway. There it is. Click on that, save these changes. Now we just need to associate this to the public subnet. Boom. And just like that, it's associated, and now traffic can flow from the internet in and out of this subnet. All right, we have both our private and public subnet created. Now, just because our private subnet doesn't have an internet gateway does not mean it needs to be entirely locked down. With an additional resource, that being a NAT gateway, we can still hit the internet from our private subnet. First things first, we need to check the access control list here to make sure that our subnets are associated. Here, test, cool, we're all good there. Now go over here to the NAT gateway page. We'll create this. So NAT stands for Network Address Translation. This maps the private IP addresses to public IP addresses before transferring information. This puts a layer of security in front of your subnet, allowing for traffic to still reach the internet while staying private. So we'll call this test NAT. We'll associate it with the public subnet. Now, if you're trying to communicate to the internet, it's going to be public. But if you're trying to communicate between another VPC or an on-premises network, then you're going to go for private. It also needs an elastic IP, as it is a public resource. So we'll go ahead and hit that button there to allocate that. Additional settings here, if you want to define a private IPv4, we're not going to do that. All right, we'll then create the NAT gateway. Now, we need to actually create a new route table for our private subnet. So we'll call this private, select the VPC, create that. All right, we'll then associate this with our private subnet, and we'll add a route. All traffic via NAT gateway, and we're going to point to our NAT gateway. Save that, and now, because of this being associated with our public subnet, we now have network address translation between our private subnet and our public subnet. So, instances sitting in your private subnet can in fact reach out and hit the internet. With that, we finished creating all the resources for this demo. So now we just need to delete everything. You can't just delete the VPC since we have some elastic IP set up, and more specifically a NAT gateway. That prevents us from deleting it right away. So we need to deal with that first. So we'll go to our NAT gateway. We'll delete it. Now, there is still an elastic IP that's associated with it that we have to release. So we'll go over here and we'll release it. We need the NAT gateway to actually finish deleting before we can do this. So we'll get back when that's done. All right, now that our NAT gateway is in a state of deleted, we can go back here to elastic IPs. Make sure to refresh this because sometimes it won't actually update and you'll still be prevented from deleting it. So we'll go over here and we'll release the elastic IP. All right, awesome. With that, we can actually delete the VPC. Go up here, delete VPC, type delete, just like that. It's all gone. Thank you very much for watching. Today, you learned about AWS VPC. Whether you're running a small web application or managing a complex enterprise infrastructure, VPC empowers you to design and control your network infrastructure to meet your specific needs. Thank you for joining this tutorial. If you found it helpful, please like and subscribe for more AWS and cloud-related content. If If you have any questions, feel free to leave them in the comments below. Until next time, happy learning.